In this video, we are going to discuss about the coldest spot in the universe discovered. What do you think of when you imagine the coldest place in the universe? You probably picture the deep, dark emptiness between the stars, a place far from any sun, where the only warmth is the faint afterglow of the Big Bang itself. For a long time, we thought that was the correct answer. The cosmic microwave background radiation keeps deep space at a brisk 2.7 Kelvin, about minus 455 degrees Fahrenheit. But what if I told you the coldest place we know isn't out there in the cosmic darkness? What if it's somewhere astronomers have been pointing their telescopes? They were studying the life cycle of stars, trying to understand how they die. In doing so, they found a region even colder than the universe's background temperature. It's located about 5,000 light years away in the constellation Centaurus. It was a puzzle. How could anything be colder than empty space? This discovery opened a new chapter in our exploration of cosmic temperatures. So, where is this natural cosmic freezer? It's located about 5,000 light years away from Earth in the constellation Centaurus. When astronomers first measured its temperature in 1995 using a telescope in Chile, they got a result that seemed impossible. The gas at the heart of this nebula registered a temperature of just 1 Kelvin. That's minus 455 degrees. It was colder than the cosmic background radiation. Nature had built its own refrigerator in space. How does it get so cold? The answer lies in a process that's surprisingly familiar. Think of a can of compressed air getting cold when you spray it. The gas inside expands rapidly as it leaves the nozzle, and that expansion cools it down. The Boomerang Nebula does the same thing on a massive scale. At its center is a dying star, furiously spewing out gas and dust. This material is rocketing outward at about 370,000 miles per hour. This rapid expansion chills the nebula to record lows. The star is shedding its outer layers in a violent final act, creating the bow tie shape we see. But the sheer speed is what turns it into a cosmic cooling system. Physics on a grand stage. Pointing instruments at that faint smudge revealed a fundamental cosmic process. It pushed astrophysicists to re-examine their models and consider strange processes in a star's final moments. The Boomerang Nebula is the coldest place we've found in nature, but humans, in our relentless quest for knowledge, have managed to go even colder. Scientists in places like MIT and the National Institute of Standards and Technology have built machines designed to push the very limits of cold. They have created environments that are just a fraction of a degree above absolute zero. First, conventional methods like liquid helium cool a cloud of atoms very, very cold, but that's just the beginning. The real magic happens with lasers. Imagine you have a bunch of atoms bouncing around wildly. That's heat, motion of particles. Scientists surround these atoms with lasers from all directions. The lasers are tuned to a very specific frequency. When an atom moves toward a laser beam, it absorbs a photon, which slows it down, like running into a constant headwind of light. This technique, known as laser cooling, can slow the atoms dramatically, to within a millionth of a degree of absolute zero, but scientists can go even further. The final step is called evaporative cooling. It's the same principle that cools your coffee. The hottest, most energetic atoms are allowed to escape from the magnetic trap. They take their energy with them, leaving the remaining cloud even colder. Through this combination, scientists have achieved temperatures of less than a billionth of a degree Kelvin. Hundreds of millions of times colder than interstellar space and the Boomerang Nebula. We have created a state of matter so cold that it likely exists nowhere else. So we've talked a lot about getting colder and colder. But is there a limit? Is there a point where you simply can't get any colder? The answer is yes. That limit is called absolute zero. Zero on the Kelvin scale. Equivalent? minus 459.67 degrees or minus 273.59 degs. At this temperature, theoretically, all the classical motion of particles would cease. Heat is the energy of motion. An atom would have no more heat energy to give up. You can't have less than zero motion, so you can't get any colder. But here's where things get really weird, thanks to quantum mechanics. The universe at its most fundamental level is a fuzzy, uncertain place. You can never know both exact position and exact momentum at the same time. If an atom were perfectly still at absolute zero, you would know its momentum precisely. It would be zero. which means you would have no idea where it is. To prevent this paradox, particles must retain a tiny residual jiggle called zero-point energy. So even at the coldest temperature, the universe never becomes completely still. When you chill atoms to a fraction of a degree above absolute zero, they stop behaving like individuals. They begin to act like one unified entity, a Bose-Einstein condensate, moving as a single quantum wave. We are not just exploring cold, we are exploring a whole new state of matter, a place where quantum rules become visible on a macroscopic scale. Why go to all this trouble? Why build these incredibly complex and expensive machines? It's not just about breaking records. Chilling atoms to extreme temperatures lets us witness the fundamental nature of reality. Ultra-cold atoms can build the most precise clocks ever imagined, so accurate they would not lose a second over the entire age of the universe. They could improve GPS navigation and timing systems. They could detect gravitational waves with greater sensitivity and test Einstein's theory of relativity with unprecedented rigor. The pursuit of cold is a pursuit of precision. Strange quantum behaviors at these temperatures could be harnessed to build quantum computers. They could lead to superconductors that transform our energy grid and enable maglev transport. This research is paving the way for revolutionary materials and technologies. The quest for the coldest spot is a story about human curiosity. We look out at the cosmos and see wonders like the Boomerang Nebula. Then we look inward into our laboratories and try to recreate and surpass what nature has done. We chase absolute zero not just as a challenge, but as a gateway to deeper understanding. The journey to the coldest reaches reveals the deepest secrets of our universe. If you liked it, tap that like and hit subscribe so you don't miss what's next.